Hello, this is Mr. Gilmore with the 4.3 Part 2 Playfair and its Consequences lesson. Today we're actually going to be able to use now the corresponding angle's consequence to determine the other angle relationships that happen when we cut through a pair of parallel lines with a transversal. Let's jump into this. First, let's review what the corresponding angle's consequence says. It says that if we have a pair of parallel lines and we cut them with a transversal, then what it results in is an equal pair of corresponding angles. So what we're using today is we're going to see the use of the CIAC to help prove the other angle relationships that happen whenever we cut through a set of parallel lines with a transversal. Let's start with the alternate interior angles consequence, or to us, the AIAC. So a consequence is of knowing the lines are parallel, that when we cut through, we're going to find that we have an equal pair of alternate interior angles. So if we take a look at our conditional, when parallels are cut by a transversal, alternate interior angles are equal. Our given is that lines M and N are parallel, and our proof statement is that angle 1 and angle 2 will be equal to each other. Notice that angle 3 has been strategically placed. Let's take a look at the proof of the AIAC. So in the proof, we start off with the given that M and N are parallel. Well, we already know then that if we cut through a pair of parallel lines with the transversal T, that it does in fact form an equal pair of corresponding angles. Thus, that's why I've strategically labeled angle 3 where it is, because I can immediately say that angle 2 and angle 3 are corresponding angles and they're equal in measure. What else can I say? Well, is that angle 1 and angle 3, since they form vertical angles, I can call them equal by vertical angles theorem. Thus, then by transitivity equality, or TOE, we have that the measure of angle 1 is equal to the measure of angle 2, thus proving that, yes, if you were to cut through a set of parallel lines, then the alternate interior angles are in fact equal. Let's take a look now at the alternate exterior angles consequence. This is, if we were to cut through a set of parallel lines with a transversal, then it would produce an equal pair of alternate exterior angles. If we take a look, again, we're given that line M and N are parallel, and that angle 1 and angle 2 we're going to prove that they're equal. In this case, they form the pair of alternate exterior angles. Again, I've strategically placed angle 3 so that it relates to angle 2 and angle 1. Let's look at the proof of the AEAC, the alternate exterior angles consequence. It is identical to the alternate interior angle consequence. It works the exact same way, that when we cut through the set of parallel lines, it actually forms then two corresponding angles that we know to be immediately equal, angle 2 and angle 3. Thus, angle 3 and angle 1 are equal again by vertical angles theorem. And then lastly, we have the measure angle 1 is equal to the measure angle 2 by the transitivity equality. So thus, we have again, when we cut through a set of parallel lines with a transversal, a pair of equal alternate exterior angles. Now let's take a look at the consecutive interior angles consequence. Now remember, with the consecutive interior angles, these are the ones that are not like the other. We are not going to prove that angle 1 and angle 2 are equal. We're going to prove that angle 1 and angle 2 are supplementary. Again, I have strategically labeled angle 3. Now we're going to get a little strategic on this one, on this proof. So when parallels are cut by a transversal, then the consecutive interior angles are going to be supplementary. So again, we have M and N parallel. We've cut them with transversal T, and we've labeled angle 1 and angle 2 as being our consecutive interior. Let's prove that they are supplementary. And for the last time, you'll notice that I've strategically labeled angle 3. Here is the proof of the CIAC, the consecutive interior angles consequence. We have the measure of angle, we have the line M and N are actually parallel to each other, and immediately we know that angle 2 and angle 3 are equal by the corresponding angles consequence. So what is it that we know about angle 1 and angle 3? Well, they form a linear pair, which means by the linear pairs theorem that angle 1 and angle 3 are supplementary. Now, we can then use a little trick up our sleeves. We have the power substitution. We know that whenever we see some relationship between two expressions, we may, and that relationship is equal, we may replace one of those expressions with the other, which means in step 3, I see that angle 1 and angle 3 are supplementary, but I know from step 2 that angle 3 is equal to angle 2, which means I can take angle 3 out and replace it with angle 2. Thus, I can say in step 4 that angle 1 and angle 2 are also supplementary, and that is by our power of substitution. So a very clever trick to actually get angle 1 and angle 2 to be supplementary in a short amount of steps. Let's take a look at our very last theorem of the day, the perpendicular lines consequence. So this one says if two lines are parallel and one is perpendicular to a third line, then the other is too. In other words, let's take a look at our diagram. We're going to be given that that line T is going to be perpendicular to line M. Well, with M and N given to us as being parallel, we're going to prove that line T is also perpendicular to line N too. So we're given again that M and N are parallel, T is perpendicular to M, but that we're going to prove then that T is also perpendicular to line N. This one we have to get down to, we can't get down any shorter than 5 steps. This is going to be 5-stepper here, just based on what we are given. So we're given that M and N are parallel. We're given that M is perpendicular to T. So immediately, right off the bat, since I know these two lines are parallel, I can claim, or sorry, perpendicular, I can claim that angle 1 is a right angle by the perpendicular lines there. Well, I know something about angle 1, angle 2. I strategically labeled them as such. I know that because lines M and N are parallel, angle 1, angle 2 are equal pair of corresponding angles. Thus, in step 3, I can call measure angle 1 equal to measure angle 2. Well, using that power substitution one more time, if I know angle 1 is right, then I also know angle 2 is right by substitution. And if angle 2 is right, that means we must know that that line T and line N must be perpendicular by the definition of perpendicular. So with that, we come to the end of our lesson, the 4.3 Part 2 lesson on the Playfair Postulate and its consequences. Be sure to be working on that worksheet, and if you do have any questions, email me. With that, be good and do good.